Hello. In this section, we do a little bit of reviewing what we did in the last lesson and then also expanding on it to be able to use the tool of factoring in order to solve equations. So we're going to start with a review question from actually the last chapter. So last chapter we solved quadratic equations of the following form. And the first day that we learned it, I asked you to just guess and check, and you just plug numbers in for x that would make the left side equal 0 because it says the right side's equal to 0. So you'd have to sit here and just plug numbers in. Try 1, try 2, try 3, maybe try some negatives. What if there's some decimals? You might have to try decimals. That's a terribly inefficient way of solving this equation. It's just sitting here guessing and checking. Instead, we realized if we could factor the equation, it'd be much more efficient. So if I can factor it, let's do that. Are there any two numbers that multiply to make 12 and add up to be 7? Well, the numbers that multiply to be 12 are 1 and 12, but that adds up to be 13. 2 and 6, but that adds up to be 8. But 3 and 4 will do the job. So let's try x plus 3 and x plus 4, and that will do it. So that's the factoring of it. Once I have it factored, if it's an equation, I can solve it. I have first thing times second thing, or if you will, red thing times blue thing equaling 0. What would x have to be to make the red thing be 0? X would have to be 3. What would x have to be to make the, sorry, a negative 3. I need it to be negative 3 plus 3. What would x have to be to make the second thing be 0? Negative 4. If either x equaled negative 3 or negative 4, it would make the original equation be 0. Here, I'll show you. If you have your calculator, you can check. Plug negative 3 in for x in the equation. It was negative 3. It was x squared. Then it was plus 7x. So plus 7 times negative 3. Then it was plus 12. And when I plug negative 3 in for x, I see it equals 0. The same will be true for negative 4. That's how we solved equations last chapter, is we factored first. Well, if it worked last chapter, it better work this chapter, and it does. So how would I solve an equation like this? I'm going to factor it first. That's why in the last lesson, we learned how to factor equations for quadratics where the leading coefficient is not a 1. How did we do it? We said, well, I know when this factors that the first term is going to be formed by the multiplication of these two pieces. What two numbers multiply to make 2x squared? It's going to be 2x and x. This is going to be formed by the multiplication of these pieces. So it's either a 1 and a 7 or a 7 and a 1. If I put the 7 here, it wouldn't work because 2 times 7 would make 14. So it has to be a 1 here and a 7 here. And they all have to be plus because everything is positive. So there's my factoring. I have 2x plus 7 and x plus 1. Now again, I have two things multiplying. You can think about it like being green thing times purple thing equals 0. Well, the purple one's easy to answer. What would x have to be in order to make it be 0? You can see I need x plus 1 to equal 0, so you subtract 1. X would have to be a negative 1. Over here, I need 2x plus 7 to equal 0. So how do I solve? I subtract 7 and then divide by 2, and half of 7 is 3.5. So negative 3.5 and negative 1 are my two answers. I forgot I left the table over here to check my factoring. 2x plus 7, x plus 1, 2x squared, 2x, 7x, 7. That's what just checked my factoring in step 1. But my two answers are negative 3.5 and negative 1. How could you check? You plug them back in. Let's do the negative 3.5 one. That one seems a little strange. It's a decimal. Let's check and make sure it's right. So what do? I grab my calculator, and there's actually a storing button you can use on the calculator. So if you've got a graphing calculator, I'm going to show you a little shortcut. If you don't, you have to do it like the first one I did. If you have a graphing calculator, you can type in the answer, negative 3.5, and you can store it for x, and then hit enter. Now the calculator thinks about x, and x you get by hitting this button right here. It thinks that x is negative 3.5. If we just type the equation in then of 2x squared plus 9x plus 7, I'm checking when x is negative 3.5, and it is 0. I could check when x is negative 1. It will work as well. So my two answers are negative 3.5 and negative 1. Let's try solving another. I want to solve this equation. Guessing and checking would be awful. For example, this last one had a decimal answer. How would I have known to check negative 3.5? That would have taken a long time to guess. Let's factor instead. If this is 2x squared out front, this would have to be 2x and this would have to be x. Now this is a minus 3, so that tells me that one of these is positive and one of these is negative. So it's either going to be negative 1 and 3, positive 1 and negative 3, or vice versa. If you want to try for yourself, pause the video now. Otherwise, I'm going to tell you that the correct combination is going to be a plus, nope, I need it here, oops, minus 1 and plus 3x. Let's check and make sure that's right. 2x plus 3, x minus 1. 2x times x, 2x squared. That's what makes the red part. And then the 3 and the negative ones makes negative 3. So my red part checks out, my blue part checks out. Now we need the middles to be right as well. 2 times negative 1 is negative 2x. 3 times x is 3x. And look, 3x and negative 2x will combine to make a 1x in the middle. So it's factored correctly. Now I need to solve it. I have this equation. Move it, give myself some space. 2x plus 3 times x minus 1 equals 0. I have two items that are multiplying to make 0. I'm going to use some colors. Purple times green thing equals 0. Maybe it's the green thing that equals 0. In that case, 2x plus 3 would need to equal 0. So what would x have to be? Subtract 3, divide by 2, and half of 3 is 1.5. So negative 3 divided by 2 is negative 1.5. Over here, I need x minus 1 to equal 0. This one's easier. Just add the 1, and I get positive 1. So either positive 1 or negative 1.5 will work. So those are my two answers to that equation. Point this out to you. Look at how many answers we get. We get two answers. The reason why is because the biggest power is a 2. Look, biggest power is a 2. There's a theorem about that you'll learn your junior year. That was kind of even true for lines. So this is kind of a flashback and a little bit of an aside. When you were solving lines, what's an equation for a line? mx plus b, 3x plus 9 equals 27. Look, biggest power is a 1 right here, so you should only get one answer, and you do. Subtract 9, you get 18, divide by 3, and you get 6. So when you solve lines, you get one answer, because the biggest power, the degree, is 1. When you solve quadratics, the most amount of answers you can get is 2. So you should be getting 2 answers when you solve these. I'm going to ask you to try. So pause the video now. First, factor. Step 1 is factor. And step 2 is to solve each factor. For solve each equation. So pause the video now. Unpause it once you want to see what the answer is. Okay, welcome back. First thing you have to do is factor it. 5x minus 1 and x minus 3 is the correct factorization. If you check it by putting 5x and minus 1 and x minus 3, you get 5x squared. Negative and a negative makes it positive 3, so there's the first and the last pieces. 5 times negative 3 will make negative, nope, that is incorrect. That's negative 15. Those need to be flipped. That is wrong. That's why we check. So when we did this before, it must have been a different problem. This has to be, the 1 needs to be here, and the minus 3 needs to be here. So you erase, that's why we do this. 5x minus 3 and x minus 1. That's exactly why you check your work, though. This will make minus 5x, minus 3x, and plus 3. So that is the correct factoring. So that means all this work probably from before was incorrect, and it is. So let's erase it, get a bigger eraser. Now it's factored correctly. 5x minus 3, x minus 1. I know they're both negative because they multiply to be a positive, and the middle term is a negative. So I solve each. Here I have 5x minus 3 equaling 0. I add 3. And then I divide by 5. You can either write this as 3/5, or if you prefer decimals, it'd be 0.6. So there's your first answer. Other one is easier. You just add the 1 over the other side, and you get x equals 1. So x equals 0.6 and x equals 1 are your two answers. We got one last one to solve for today, and then that'll be it. How would I solve one like this? Well, first note, How is it different from the other ones that we did? All the other ones had it equal to 0, and you need one side always equal to 0 because you always need two statements multiplying to make 0, because 0 is the only number in the world that I have two items multiplying to make 0 guarantees one of them has to be 0. That will not be true with any other number. If I had the thing equaling 10, is it a guarantee that one of these has to be 10? No, it could be 2 and 5. So you need it equal to 0. So how am I going to get these equal to 0? I need to add this 5 over to the other side first. I need to move it. So when I move it, I'll then have 3x squared minus 16x plus 5 equals 0. Now I need to factor. I know that the first part is formed from multiplying these two pieces, and they have to make 3x, so it's 3x squared, so it's going to be 3x and a 1x. Now I know it needs to multiply to be a 5, and it's positive, and the middle is negative, so they both need to be negative. So it's got to be a minus and a minus. This actually, so it's either a 1 and a 5 or a 5 and a 1. The 5 has to be here, and the 1 has to be here. I can do a little mental math here and see 3 times 5 would make negative 15x's. Negative 1 times the x would give me another. So this is going to check out. I already know it. 3x minus 1, x minus 5. 3x times x is 3x squared. 3x times minus 5 is minus 15x. Negative 1 times x is minus 1x. Negative times negative makes positive. 3x squared, check. Negative 16x, check. Positive 5, check. It checks out. Now I just need to solve. Either 3x minus 1 equals 0 or x minus 5 equals 0, because these two items are multiplying one another. First expression times second equals 0. One of them needs to be 0. This would have to be x equals 5. This one you can almost do in your head. Add 1 and then divide by 3. Hope you can follow that. You're going to get 1/3 or 0.3 repeating. And that is it for today. That is how you can use factoring to solve quadratic equations.